What is fit to be an atom, and what was it considered to be throughout the history? Today we will find out. So to start off, in 400 BC in Greece, a philosopher named Democritus proposed his theory of atoms.
Bro, you need to hear me out. What do you get when you cut something endlessly? I don't know, man. Did you see my marijuana? Somewhere, I can't find it. No. I don't know, and it wasn't marijuana. It was just olives, and now it is stuck in my nose. Anyway, do you know what we get if we divide something forever?
He's kinda gay.
It's not gay, come on.
He's kinda gay.
So what is the atomic model proposed? In 1804, a scientist named John Dalton came forward and said that atoms are indivisible and are smallest particles in unit.
Bro, isn't that like my idea? Your idea, more like our idea.
But he started the revolution about the atoms, like what is an atom?
So what is the good thing about this, I hear you ask? The good thing is now atom has a shape, it is spherical. It also explained what it could do. But negative things. The model was well obvious and didn't explain about any electron or proton. Then came J.J. Thomson. He proposed his so-called plum pudding model. So the model is that atom has protons and electrons fixed into it. So what new things does the new model explain? So it was the first model to include about protons and electrons in an atom. So what are the cons? It never explained how both proton and electrons are together like that. And also Gall-Foyle experiment came and thrashed the concept.
What exactly are these protons and electrons anyway?
To know more, first we will learn what is Gall-Foyle experiment. It's rather complex, but you can look about it in YouTube. The use is that it showed that something called proton existed, which had positive charge and has +1 charge. Cathode tube experiment showed something called electron existed and it had negative charge, exactly opposite to proton. Then came Ernest Rutherford in 1911, he said,
No. The atom model isn't right. It rather represents our solar system.
What was the model again? Let me try my paint. Oh, it always sucks. Anyway, his model was compared with solar system, with protons and neutrons in center and electrons revolving around like planets. So wasn't this quite simple? Well, yes, but actually, no. In his time there was no evidence of neutrons in atom. So it was quite a gamble he took. Now what is this neutron and nucleus again? Neutron is the chargeless particle at center of an atom. It could be compared like a paperweight for an atom. Nucleus is the center, where both proton and neutron coexist. Now the pros of this atom explain better about the proton and electron inside atom, also about the neutrality of atom. It also could explain about the Gall-Foyle experiment. The cons? Electrons rotate without falling into the nucleus. But how? Then came Niels Bohr. After 2 years, he just extended same model by adding a new concept, called orbitals. It is rather complicated to explain, but for now assume it is a fixed place where electrons rotate. Why? For stability, of course. Now let me bring back my paint skills.
Garbage.
Anyway, this is the same, but now it has orbitals, in which it moves and doesn't require further energy. But aren't both models awfully similar? Yes, it's because Bohr actually worked for Rutherford before. So they were basically teacher and student. So the pros? It could explain all the previous things, and now it could explain how atoms gave colors when given energy. But the cons were it couldn't explain Heisenberg principle and could only explain about the different color emitting by atoms with single electron, and failed for atoms with more than one electron. So weren't all the previous models enough? Why new ones? Yeah, but science is all about much better models than previous ones. When all the physician gave up, Schrödinger came to the rescue. He just killed all the older models with including actual amazing maths into his model. He was like,
I'm about to end this man's whole career. What?
so what new could he propose? He started comparing an electron from a particle to a wave. What is a wave? I'll put videos about it in description. Electrons follow orbitals in atom, but rather in a weird random way. Now, let us compare with previous model. You see, I can paint well. Now electrons move, but the position is unclear, so we assume these blue places that electron could be in this place. So electrons can exist all the places where it is light blue, see? So this is an actual picture depicted for atom, and there is high chance for electron to exist in these light blue areas.
So are all these orbitals, or the places where electron exists, circular or spherical in shape?
No, I never actually said that, did I? That is why the equation of Schrödinger, it shows the possibility or chance at the space around nucleus where the electron can be found, the orbitals, or can be in various shape. So the so-called shape you perceive atom could change. Like, check this out. This model has the shape of orbitals for hydrogen atom. More information is rather complex, but I'll still link about that in description. So with that, our last updated model of atom ends. So is this the correct model for atom? Maybe or maybe not? Science is rather constantly evolving, so we could see better atomic models in future. So we have to await, but with this we come to the last accepted atomic model. So that's it with the video. Thank you for watching. Do like, or even better subscribe.